This is Regenerative Skills, the podcast helping you to learn the skills and solutions to create an abundant and connected future. I'm your host, Oliver Gaucher. Through their diverse range of publications, New Society Publishers' books explore topics that are at the forefront of creating positive change in our world. From regenerative agriculture and permaculture to social justice and eco-conscious living, their books cover a wide spectrum of subjects that empower readers to lead more regenerative and fulfilling lives. Now, whether you're a seasoned environmentalist, a curious beginner, or someone simply seeking inspiration and guidance on your journey towards regenerative living, New Society Publishers is here to support you every step of the way. Now exclusively for listeners of this podcast, you can use the code SKILLS25 and receive a 25% discount on all ebooks at newsociety.com. That's all one word and lowercase, SKILLS25 on all ebooks. So level up your knowledge today at newsociety.com. Hey there everybody and welcome back. So longtime listeners of this show will know that soil health and deep soil science are not really my specialty. I've done quite a few interviews on soil over the years, but I've usually looked for broader patterns and simple concepts around soil health and function. And then I've left the lab work and the understanding of all the microbes and the fungi to others. A few weeks ago, however, I was invited by my friend Isa to a Soil Food Web alumni gathering. And there I met so many fascinating people who spoke about their projects and their initiatives with farmers and other organizations, which ranged from production and crop health goals through AI learning and even national security collaborations. And one of those many wonderful people that I met was Tanja Dekker, who was a soil life consultant and educator specializing in adaptive land management with extensive expertise in regenerative agriculture, sustainable food forest design, and eco-conscious entrepreneurship. She leads her organization Festina Lente, inspired by the alchemical concept meaning make haste slowly. Tanja is passionate about implementing regenerative practices that prioritize environmental health and community resilience. Now, in this episode, we cover a wide range of topics from the family tragedy that led her to shift careers and work to restore soil, through her unified theory of the trajectory of the natural world and our role in it, all the way to realizing our potential as a keystone species, and the practical steps involved with analyzing your soil and broader ecosystem in order to take actions that enhance its health and vital processes. Now, this episode winds through curvy roads of philosophical concepts and down-to-earth steps for taking action in your own context. And so with that out of the way, I'll hand things over now to Tanja Dekker. So welcome, Tanja. It's a pleasure to speak to you again. It's a shame that we didn't find the time to do this in person while we were on that gathering together, but I'm really glad that we have the time today. How are you doing?
I'm doing fine. Yeah, it's nice and cold here, so I like the climate.
Yeah, it's nice and cold here now too. We've actually had some good rains. It's been an above average rainy year to compensate for some of the drought of the previous years. But why don't you tell our listeners about where you are and what it is you do for work, which is why we got together in the first place.
Right. Well, I live in the Netherlands and I love to help other people regenerate their soils. And I do this worldwide. And so I get contacts from Australia, Africa, all of Europe, sometimes Brazil, or wherever people need to understand what it takes to regenerate soil and they know how to get a hold of me. I love to work with them, and I do. And in order to do that, I let them get to know their own soils, right? Because we don't know our own soils. And so that got me into jumping into it more and more detail because there's so much to tell about soil.
Indeed. But you've had an indirect way of getting into this sector. How is it that you began to work with soil in the first place?
Yeah, well, that's actually a bit of a shocking story. My husband got Alzheimer's on a very early age. And it turned out after a lumbar puncture was taken that the cause of it was the poisons that were used in agriculture. So they're directly noticeable in his brain fluid. And that actually stopped me in my tracks. And I thought, my God, what a incredible impact these chemicals have. And after he died, I decided radically, I'm going to do something about this. If I have maybe 20, 30 years more to work in my life, I'm going to dedicate myself to restoring soils without chemicals. And ever since that time, I've noticed that there's like a huge wave of people getting ill with Parkinson, which is now directly connected to the use of pesticides, herbicides, fertilizers. So I'm here to help change that.
And so, in understanding that the chemicals are the cause of these increasingly common diseases, where have you been able to make progress in this area in charting a path or helping people to discover a process for getting the results that they want in their cultivation through their soil without having to use the chemicals that are associated with these diseases?
Yeah, it's a very good question. And, in order to answer that, I go way back to the beginning. How did we get on Earth? Because one of the questions I get most is, what's this stuff about minerals, actually, right? Everyone is talking about minerals. And I go, really, that's a really good question. Let's start there.
Okay.
And so if we want to talk about this, we actually need to go to the prequel of the Earth, because before the Earth was an Earth, it was a gas giant waiting there. And it took a supernova 200,000 light years away from us to blow, and then that cosmic rubble came our way and it got caught in our gas giant. And then the Earth had minerals. Are we there? No, we're not there yet. Now it's a fireball, right? But it's standing still in space. So now it took a huge collision with a planet called Titan. And it did a couple of things for Earth. It made it spin on its axis, but it also tilted it 23 degrees. And it got a lot more rubble, of course, and this turning around made Earth round again. And then we got a moon, which was extra good because now we could hold on to our oceans because we had a movement. But with the moon so close to us, as the Earth was cooling, it would also crack open the crust. And so we got tectonic plates, which is unique in our solar system. You don't see that in the other planets around us. And it is
because of the gravitational pull of the moon, the same force that causes the tides and such?
Absolutely. And so we have tectonic plates, but that also means that the Earth can regenerate, right? Because it can remineralize itself every time and again, which it did in the early stages with all of the volcanic eruptions.
So you're talking about the process of the tectonic plates moving around, and as the magma comes up to replace absences or pushes plates up into mountain ranges, these minerals get mixed up in their strata layers, and that is the process you're talking about.
Yeah, that's the process I'm talking about, and that's one of the regeneration capabilities the Earth has. Of course, it has some destructive sidekicks as well, right? Extinctions.
Sure.
But
we could almost put those into the disturbance regimes that manage all of the ecosystem balances that are required to reach something of a homeostasis instead of spiraling down through entropy.
Right. Yeah. It doesn't stay, it's in movement all the time, our little Earth. So let's go back. We have minerals now. We are turning, we are round, we've got a moon. Can we eat those minerals? No, we can't. So what we're waiting for is our first colonizers, which are the bacteria and fungi. But these are the ancient ones, and they're all anaerobic, right? Because Earth hasn't invented oxygen yet. So the bacteria for hundreds of millions of years go roaming around the Earth, and they have the enzymes in their bodies to snoop molecules off of the Earth. And then they do something magical, Oliver. They produce something unique, organic matter. So it takes 100,000 millions of years for them to produce a lot of poop. And then they can hide underneath this poop when other microbes invent oxygen, right? Because oxygen is an incredibly versatile molecule. It wants to react with everything. But then if it does, yeah, it's very corrosive. So it's a good thing oxygen came after we received our iron, because if we had received iron after oxygen, it would have rusted all. But we need the iron for very important things. Our first weapon on Earth is called superoxygen. And that is for bacteria to shoot at other bacteria to find out, are you a good guy or are you a bad guy? And so our first weapon on Earth is oxygen.
It is wild. Yeah. I mean, look, I've studied some of this stuff, but I love the way that people put this together in different ways and tell it as a story. So we have now the building blocks for an organic revolution, you could call it. And life starts to colonize from bacteria to more complex organisms and multicellular organisms. We're also starting to move out of the oceans. Where are we taking from there?
Well, I want to go back, before we go back and over the oxygen hump, I want to emphasize the fact that fungi and bacteria were already working symbiotically together. Fungi are very sloppy eaters. They eat outside of their bodies, right? They release acids, and that's the way they get the molecules of the metals and nutrients loose, but they're not fast in eating, and so bacteria would quickly eat. So they got to know their partners. And so when we do end up with water and little water plants living in the water, and fungi are starting to make contact with plants, they already know their companions, which are the bacteria. And one of the first services they said to the plants, can we do audition? Can we help you? We have some friends called endophytes, which are bacteria that are willing to give up their lives, but, perform a function in your structure. And so the plants were probably pretty impressed because they could withstand a lot more after that. And I think then the trust was there and they started to completely work together. And this is how the fungi coaxed slowly, but they coaxed the plants onto land, saying, look here, it's unoccupied. There's a lot of stuff you can do here. And then in no time, the earth became green. But we took out all the CO2 out of the air, and we caused a third extinction, and the earth became an ice ball. So after that, we had to come back as the earth, and it began producing ecosystems. Trees, plants that were trees before now grew roots. They learned how to make roots. Also, that ended in an extinction, but this was because of meteorites, volcanic action, and that's too much of a mix. And it was the fourth extinction. We had a fifth extinction, and that was after the dinosaurs were killed off. Again, meteorites, can't do much about that. But then the Earth came back with complete ecosystems, complete self-sustaining ecosystems, meaning if we look at grass, right? Grass is a plant which is unique because you can eat the top off and it will still grow. You can't do that with trees. If you take off the top of a tree, it can only grow wider, but it can't grow higher. Yeah, from side shoots it can. But grass you can eat and it can grow again. And so grass comes with herbivores and with a microbiome in the soil that can take the manure from the herbivores, transform that and give it as food to the grass. So it's a complete self-sustaining ecosystem.
Perfect example of coevolution.
Absolutely. It's all co-evolution. And on the whole earth, it was one big food forest.
Yeah.
Because you can imagine that animals would roam the earth and would deposit the manure with seeds in it. And if it was good ground, good soil, an olive tree would blossom there, or an apple tree, or, whatever they carried around. And so it was one big food forest. And then we came.
Okay, so we've gotten to a point where there's complete ecosystems and life is spreading and moving at the rate that, let's say, the conditions allow for it, right? As fluctuations in temperature and rainfall and other things create new possibilities for species to expand out. You have this coevolution process. There's one thing that you skipped over that I would love to get your opinion or your take on, which is the ability for mycorrhizal or saprophytic fungi to metabolize all of the lignin that was accumulating from all of these plants, because that didn't happen all at once. And it's the reason why we have these reserves of fossil fuels that we do now.
Totally. Yeah, that's totally true. We go back to when the fungi coaxed the plants onto land. Once they coaxed them onto land for, 100,000 years, forests would grow and they would die, and forests would grow and they would die, but there was nothing on Earth yet invented to break down the lignin, and it did become our coal and our oil.
Right.
In that
People often talk about fossil fuels like they're all dead dinosaurs. Or like, no, it's actually dead plants.
it's dead plants.
A
Yeah,
lot of it is anaerobic decomposition of necromass from plants in places like swamps and wetlands and bogs, right? That's where
totally.
most of this stuff is accumulated.
Yeah, it's horsetail mostly.
Oh,
Horsetail
wow.
used to be
Yeah.
80 meters high. Plants were huge, but then we had a different oxygen situation in the air. Yeah. Yeah, it is pretty amazing that in that extinction event, so much organic material was present. The Earth was covered in ice. So underneath the ice, the fungi created something new, and those became the saprophytes, the ones who can break down the lignin because nobody could before. Yeah, so that is still a very interesting story, how the mycorrhiza fungi will serve life but cannot break down life, right? They can't break down, they can only serve life. And then you have the saprophytes to break down. And of course, you have the parthenogenics as well, because we all need that too, because it's a one big civilization. And sometimes you need to take something out, or something. A tree wants to say, I want to give up my life.
It's your checks and balances.
Yeah. And so then you send, or you invite in your parthenogenic fungi and ask for your end of life. Yeah.
Yep. That's how it all circles and gets re-metabolized into the system and such. Okay, so that brings us to where we are now, and also some ideas that, since learning about how it took fungi a while to adapt to this abundance of a food source and be able to metabolize lignin, maybe there's opportunities for biotic evolution to help us with our massive trash problem, like plastics and other things that currently have no natural way of degrading into or being recycled into the food web.
Yeah, well, actually, when your beneficial microbes see an ecological problem, they start to solve it, because that's what they've been doing for hundreds of millions of years. So yes, they are aware of the plastic in the ocean, and they're chewing on it and changing that environment. I think the same thing will be true of PFAS. I hope it will be true of PFAS.
If only they could get a move on that, that would be lovely.
Yeah.
It would also be nice if we stopped producing it, but
yes. Yeah, the forever. Because if you look at those horrible accidents like Fukushima, you see fungi come into existence who can take care of the radiation and make that into something completely benign. And plus, they will make sure they don't give anything that is not life-giving to the plants and the trees that are living there, which I find amazing, and a testimony to how much they really serve life. Which is what I'd love for people to understand, how the Earth is one big organism, actually.
Yeah.
And how it is actually not so much so that we are the only species looking out for other species. I'd love for us to become aware of the fact that all the other species have been taking care of us for all those millions, hundreds of millions of years. We've been taken care of. Instead of that, we are taking care of them.
Yeah, and this fits with the narrative from some philosophical writings that I've been piecing together into the closest thing I have to my own worldview, which is to suss out the patterns of the trajectory that life has been on, at least on this planet, since we've been able to investigate it. And as the simplest forms of life, as multicellular organisms, we're able to develop the capacity for growth, adaptation, reproduction, all of these simple functions that we attribute to our definition of life. They start to evolve into greater forms, mostly through collaboration, right? This is exactly what a multicellular organism is. It's a bunch of different organisms that have come together and figured out how to not only cohabitate, but make use of the speciality of each one of their functions in order to accomplish something that together they would not be able to. And we can easily identify this in what we would think of as a whole organism, let's say a plant or an animal, which is a whole bunch of different cellular functions merged into, we could almost call it a separate being, but of course they're interdependent on so many other processes and interconnected relationships, not only within food webs, but in cycles of minerals and gases and others that create the conditions for them to thrive, to grow, to adapt, and so on.
Yeah.
Now, obviously, there are also these checks and balances that we've talked about as well. But as we continue to extrapolate this trajectory up until the current day, everything has been moving towards greater complexity and more robust interconnected relationships that create a resilient system. Obviously, with those anomalies of the extinction events, to reset the system at key points. And we could say that there is either a intelligence checks and balances system behind it, or random events that perhaps were not anticipated, but the result is more or less the same. And life finds a way of reestablishing this complex interconnectivity. And I mean, obviously, this is not held just within the organisms that I described, but we can start to look at it from a further distance and look at how biomes and ecosystems are macroorganisms of their own, and even put that into the planet being one of these macroorganisms like you were describing. So I think we're on the same page here. I'll let you take it in the next steps, and then I'll jump in with how I see this kind of moving out into the future in the variety of options that we have to influence if we are the ones at the driving seat.
Yeah, I think along the same lines, but I wanted to go back and see how it all started again.
Mm-hmm.
So I went back to the old archaeas, and they were looking around to see who else was around, and they ran into a bacteria that later we have become to call a mitochondria.
Mm-hmm.
So in the neighborhood of an archaea, a mitochondria could, because that's what it does, it produces energy. It could produce energy better in the protection area of the archaean. And so at one point in time, it asked to be engulfed. And that's when we got the eukaryotes, the true cells.
Mm-hmm.
But this means they both stayed alive, right? The thing is, the mitochondria inside the archaea is way better at functioning as a mitochondria inside the cell than outside the cell. And in your body, you have 50 trillion cells with a mitochondria in it that is an independent acting bacteria in service of your life, because it gives you energy. Anything you do requires energy, and it's the mitochondria in you that give you that ability. But what I found so interesting is that outside, before this happened, the mitochondria probably blinked on, off. But once it was inside the body of the archaea, it could perform perfectly as an energy source. And I think that this is the clue when we're trying to figure out how do we work together, is that you notice that you work way better in this environment, or you excel when this or that condition is in place. Mm-hmm. And then you go and seek those situations because you love to excel. People love to excel and contribute. And I think that's the clue.
And is it a matter of figuring out from a biological level where these conditions are, or how you can bring them about in order to thrive and excel as an individual? Or do you look at it from a different perspective?
It's so interesting that we think of ourselves as individuals, because if you actually look at how we move and change, we move and change in processes. We humans, we live in communities, we actually move in processes. So it's interesting that we keep thinking of ourselves as individuals. Yeah.
And that is kind of what I was saying too, how every time you take a little step back, you recognize the interdependencies within these macroorganisms at different levels of which you're observing, right? So we can look at ourselves, because we move fairly independently of other elements as a whole unit, as an individual. But as soon as you take one step further back, you recognize how interdependent we are on all of these other processes, life forms, cycles, and such, that without any of them, our individuality would not exist either. And so there's no real separation, even on the scientific level, distinguishable limits between where one individual, I say in quotes, ends, and where the connection to the macroorganism that supports it begins.
Yeah, I find that so interesting too, because those 50 trillion protozoas in your body decided to work together.
Yeah.
Yeah.
Challenging the notion of free will.
But they did really organize themselves, and your liver does something your heart can't do, and it's impressive to me. Going back way back again, so we have this point that goes to animals, we have a point that goes to plants, right? When you have a cyanobacteria marry an algae and they start producing plants and oxygen. It's interesting to me that some of these cells did organize themselves into a body like your body, but other cells, like animal cells, really only want to hunt. So we still have two energy patterns going through us, and that is going hunting and getting it, at the same time also being organized to work together, which I find interesting. And when I look at the microbes, how they're organized.
Sure, and it's very similar, and I'm glad you brought up the analogy of the gut microbiome. It would be similar to the hubris of an individual human being like, I'm in charge here. I make my own decisions, like a single bacteria in your gut being like, no, this is all about me. I'm going to run the show here. Not realizing that there's a very, very tight feedback loop on the exudates from that microbe, the input from the food sources, the communication between what is almost as complex as our brains in constant communication with sort of the command center at the cerebral level, and how much feedback and information is coming from your gut and informing the decisions, the moods, the emotions that you feel. Like it's not different from us being a single minor player within a macro ecosystem or organism where these feedback loops are constantly going on, and how we interact with those means that we can behave like a malignant tumor or as a symbiotic, let's say, keystone species, accelerating the processes and improving the conditions for more complexity and more robust and interconnected relationships.
Yeah. And then see what pays off more, right? I mean, some people really try to use the other route.
And I think our difficulty is in our inability to be aware of those interconnected relationships at the moments of making key decisions, and a general inability to see the timeframes in which things are required to get established, to gather feedback on their efficacy, and realize if the decisions we've taken are actually beneficial to us, because they may be in a short term, but are certainly a form of degradation over the long term if we look at the trajectory of how we've been behaving for at least the last hundreds, if not couple thousand years.
Yeah. And what pointing back to microbes again, I mean, there are anaerobes and there are aerobes, right? The ones who love oxygen, the ones who don't love oxygen. Now, it happens to be that a handful of those anaerobes are completely deadly to us humans. And so we kind of look down on anything that's anaerobic. But that's not how it's done in the microbial work, because every process is important, right? So what the anaerobes are capable of doing is changing minerals and make it into gas forms, which is what we also need. But the aerobes are really good at taking those minerals, making them organic, and then feeding that to your plants at the root system, which is what exactly happens in your gut as well. You're not feeding yourself. You can't feed yourself. The only one who's feeding you are the microbes in your gut.
Transform your input into a form that can be metabolized by your organs and your...
Yeah. And so who are you feeding? Be aware, you are feeding your microbes, not you. I mean, and they are feeding you. So if you want to be fed well, you have to feed yourself with something that they can process.
And you can also easily, depending on what you put into your body, throw off the homeostasis or the equilibrium of the bacterial colonies in your gut. That can cause all kinds of gut dysbiosis, as I have been trying to repair for the last 15 years.
Yeah. And so antibiotics, we have been way too generous with it. Generous is not the right word.
Yeah, we've been
over-applied it.
Very much so, and been very careless with them as well.
Yeah. Now, I want to talk to you about something else, and that is in this philosophy of comparing stuff. right? If I look at pioneer plants, which are weeds, they are also looked down upon many, many times. But I love them because they have grabbed all of that early organic material and held it together with their special root system. They have a completely different root system than from the higher successional plants. But just like we can have thoughts, like little brain farts that really don't mean anything, which could be weeds, right? We could just not pay attention to those thoughts, let them go, and wait for our more mature, higher successional thoughts to emerge, like beneficial, plants that produce a fruit or an apple or something. And to take care of ourselves more as an ecosystem, and not to go weeding out those thoughts as if they are unwelcome or we need to suppress those thoughts, right? No. Let them not do anything. Just let them, and have higher successional thoughts come up naturally.
Oh, I really like this analogy. So I would maybe connect those lower successional thoughts to states of mind, such as deficiency, or this is often talked about, a mindset of scarcity. And in a scarcity ecosystem or a scarcity mindset, you have your earliest succession of plants or life, or in your case, thoughts, right? These are the things that are required to come in and take up space and create the conditions for the next succession of thoughts, or the next hierarchy of life in a successional model, right? So as you start to improve the conditions that allow for higher succession thoughts or life to come in, you're going to start to reap a benefit because they are able to bear fruit, or in different ways. I think this is what you're saying. Correct me if I...
Totally. And have that attitude of, oh, this is curious, this is interesting, this is the preconditions we need to go through, right? Yeah. So be welcoming and not be so critical, because that's what I noticed with a lot of us in the Western world, at least, is we're so highly critical of ourselves that it's difficult to have any other thought than being critical. So there needs to be more love.
Well, in very much the same way that I work with land managers and farmers in talking about, like, if this is the weed that you don't want to see present in your system, well, instead of attacking the symptom, let's go to what has caused that to be to want to live in your fields or on your land, right? So what can we do to the land to create the conditions to see volunteer species of the types that you wanted to plant in the first place, instead of trying to force later successional species into a very early succession, let's say, soil condition or other ecosystem condition?
Yeah, I'm so excited that you say this, because it's those pioneer plants, those weed plants that are actually trying to balance the chemical imbalance in your soil, because they are capable of taking up copper or whatever toxicity you might have. And so you can look at them and ask them, what are you telling me?
Yeah. So that takes us to the more practical side of your work. Can you tell us, first of all, the environment in which you work in? Because I think a botanical garden, with all of the incredible unique inputs that you get to work with for compost feed and different trials that you get to work on, is fascinating, and many people don't get that opportunity.
Oh, goodness, Oliver, that was like a candy store. I worked for the botanical garden for 5 years, and I got to do everything with compost. So I really, I had so much starting materials. I've never had that luxury again, right? Now, if I need to make compost, I really have to look for starting materials and source it. But there, it was like I said, I was like a kid in a candy store. And I got to make all kinds of medicinal compost for the collection plants that the botanical garden has, and was successful in treating them. And after that, when you see them work and solve problems, you have such faith in them that once I stepped out of the botanical garden, I was kind of shocked by how people didn't know about microbes. What? You don't know? And then my long journey in education started. So I thought, I need to tell them how much they do and how wonderful they are. And you can look at them with a microscope. And then I went around and gave lectures and showed them the microbes that are in their gardens or in their patch of whatever they have, to introduce them to the microbes, because they look like jewels, right? They're gorgeous to look at.
They do, yeah, and all the different types of filters and lights and mixes that you can put in this. I'm only just starting to scratch the surface as I've gotten to know the community that came together in our gathering and have been teaching me so much. It's been fascinating.
Yeah, what I also love about microscopy is that you can see what's not there, right? So what I want to see in that top 10 centimeters, which should be the humus layer, the A horizon, where everything that can germinate from that point and grow down and grow up. So what I should see is 60% organic material. Well, you can understand in most of our soils, not even 1% of organic matter is visible. And so I can see the lack of organic matter. So I look for what I'm not seeing. I need to see a necromass, right? I need dead material. I need dead organic material. I don't see anything. And so when I do see a soil with dead stuff, I could kind of really, I start to smile and I feel happy. A dead microarthropod leg, for instance, or I see, oh, nice, big clumps of organic material. Now I get to dilute my stuff because now I really need to look for my microbes. I can't count them. So many are there, which is rarely the case. But I have found some beautiful sanctuaries where there's a lot of biological information. And I tell you, Oliver, I've seen so many soils with completely stripped of all information, right? No organic information. It's just parent material, what I'm looking at. And that's all over the world. And I'm worried.
Yeah, it is concerning. So in that observation and seeing all of these soils, where do we start to create a process to regenerate them in the broadest sense? Because obviously that's going to look different based on the needs of the client, of the operation that's happening on top of it. Walk me through your process to get to the bottom of how to put it on a different trajectory.
Well, when I do work with a grower, I first need to connect with him, make sure that he understands that the soil is his production motor.
Yeah.
If that connection isn't there, I really have a difficult time starting, because if the soil is not a real priority, I can't be effective, because his mind will trail off or he won't listen to what needs to be done. That first connection needs to be there. The soil is your production motor. If you can't see that, I can't work with you. But after that, I do completely explain the soil layers. If you understand the soil layers, you will understand that you never want to do any tillage, because you're destroying a civilization below ground. And in that civilization, you want everything in there, including the military police, right? That you send out to knock down rebels. That's what we do in our civilization. And so we want everything in there. So it doesn't mean that you don't want to see any pathogens. Yeah, you want to see them in spore form, or that they can get activated, because some fungi you want to have, if there is, an insect plague, there are some fungi that can push up their hyphen above ground and take them out. And sometimes as a civilization, you want to do that if there's protection needed to be done, because a plant will go into stress and call out, hey, help me, help me. And then the fungi will come into action, take care of the insects that are being too much of a pressure. And that's how you get balance into a system. So you need everything. But if you understand that, you don't want to then till that, break it all up, because then they have to recreate everything again, make water stable aggregates, make air passageways, rearrange everyone, because you have oxygen levels that you can handle or cannot handle. And if you dig deep and you bring that up, those need to not have oxygen, and exposure will kill them. And those that need oxygen are now there where there's no oxygen. And so you're killing a lot of stuff.
Yeah. So I want to challenge that real quick, because there is this general sentiment that tillage has no place in regenerative agriculture. And I was wondering if you can give me a scenario in which limited tillage, because that's the other thing too, is it's not one thing, right?
No, it's not one thing.
Can mean many, many different ways of intervening with the surface of the soil. And so are there types and applications that you have seen in which tillage is recommended, or a tillage regime is part of a regeneration strategy for your soil?
Yeah, because the way you till, don't don't flip it around. That's not what you should do.
Probably
But if
not too deep either.
Right, but if you cut a line or you make a furrow, you do cut through fungi, but they have the capacity to reconnect, right? So you make a cut, you put your seeds in, but you don't actually disturb all that much. It can reconnect, it can find itself again. But if you completely
Polarize everything,
yeah, then everything's destroyed, and it's those hyphen. It's the fungi that are capable of doing all of the difficult work, right? I mean, phosphorus is difficult to find, sulfur, that's their job. Water, anything that's difficult is actually the job of fungi to give to the plants. So what you want to do is to create the conditions that they can do the work for you. They can water the plants for you. They can nurture your plants for you. You want to make those conditions good. But yeah, you can cut through them, but don't open it up, and then they can reconnect. So I think what it is, Oliver, is that we need to get eco-literate, understand how soils work, and that they can take a blow and they can restore and they can take many a stress, but we can help them. We can be smarter in how to work with them.
Sure. So a more complete understanding about everything that's happening with the different intervention and tool options that we possess right now can make sure that we don't just do mindless damage without the recovering actions or inputs, and that we think through the full effect of the decisions that we make.
Yeah, we overlook them, right? I mean, I hear people talk about cutting away woods forests because we need more roads. And I go, you're talking about multi-species, right? We're not just talking about your trees that you're cutting away. Any animal living in and around those trees are going to be damaged, if not lose their habitat. I mean,
it's literally impossible to remove an element from a macro ecosystem and have everything else just readjust and take it in stride. I mean, there will be ripples through that, if not major damage, that cannot be replaced until that element is replaced and the relationships are reestablished that allowed it to reach the level of health or homeostasis that it was in before the impact.
Yeah, so let's develop an eye for that, for the bigger picture. Let's not look at one species, but we always want to have a self-sustaining ecosystem, something that can work on its own without too much intervention of us humans. But if we need to be intervening, right, because some products we can't grow without our help, we need to take our position and do it without damaging other species.
Indeed.
Yeah.
Okay, so let's go back to this creation of a process for soil regeneration. First, it was understanding whether or not the client has the appropriate priority and recognizes the role of the soil as the engine for their production system. Can you go ahead and take me forward from there?
Yeah. And then we do a soil assessment with direct microscopy, so I can explain the soil layers while looking at his soil sample, because it's obvious what's lacking, what's not there, and what is there. And then we make a plan how to solve it. But I do let them get to know their soils. Like, do we have compaction? Do we have water infiltration problems, which is very common?
Yeah. They tend to go together. Poor soil conditions, poor water handling and infiltration systems.
Yeah. And then what's required? How can we solve it? Well, we humans, we're kind of a little bit too big to go gluing all kinds of little dots of organic matter. So we need to let that be the job of microbes. We need to have our jobs and we need to give them their jobs.
So one thing you said is you went straight to soil microscopy, which is really meant to understand the life forms that are in the soil and the function or the connections in the soil food web. Do you also pair that with other analysis, chemical analysis, mineral assessment, things like that?
Yeah, actually, before I do microscopy, I do the Slake test, because that means you take a clump of your soil and you put it in a glass of water, hopefully with something in it so it can stay on top of the water.
Or a little screen. I've made videos on how to do the wet Slake test to
exactly
stability. Yeah,
exactly. If the aggregates stay stable, it's worth my time and the client's time to look at the microbes, because then I know we'll see them. Yeah. And if it dissolves right away, it's just, I know I'm going to see bacteria and that's it, because the others aren't there. They need each other's secondary metabolism products in order to make the extra glue components to
The glomulin, yeah.
glomulin. And so that it's, but it's the same thing with making fulvic acid or humic acid. It's not one that makes it, it's a group effort to make these acids.
Sure. And that's why looking for evidence of them is so important, because
Yes.
if it's present, you know that these other elements have to be there, because that doesn't
Yes.
get produced without a community.
Yeah, so it's very predictive, right? What you see in those top 10 centimeters is very predictive to what's happening below that. And then you can design your interventions, right?
Okay,
Because
so
now
give
you
me an
know.
example about how you use that information to then design an intervention to set it on a better track.
Yeah. So most of the time it is compaction that is the biggest problem. And when you work with dairy, it's grass and maize that is mostly used, produced. And so it took 2 years of repairing the grassland with, I think we put 5,000 kilos of compost on that soil, because when I first look at the soil, it was like in osmotic shock. You can see that through your microscope. And that is that all these elements kind of repel each other. And it's like they're floating in the vacuum of space. That's what it looks like, osmotic shock. And so too much fertilizer, so much fertilizer that it's any water that comes in it, it's occupied immediately. So it took 2 years to repair that, but that was good. It did get repaired. So it depends on how many points, -2. We started at -2 to get anywhere, but we made it. But it's the microbes, of course, who did it. And you do have to then produce a lot of compost. That farmer became incredibly efficient in understanding, oh, this is starting material. I'm going to place this here outside of the rain. Hey, yes, I do want those wood chips. Come on, leave them here. And then he started to make loads of compost on his own. And if you know how to make your own extracts, which is not difficult, right? It's washing the microbes off your organic matter and invite them into water, because it's easier to spread the water than something solid like compost. That's what extract is. It's easy to explain these things to farmers, and they're real smart and good with equipment. And if there's a technical problem that needs to be solved, they're very creative in solving the problem. Yeah.
All right, so I want to take some time to dissect this, because people associated with the soil food web school and who really focus on microbes have sometimes been accused of using compost as the cure-all for any possible soil malady or lack of function. And there have been some pushbacks from other parts of the community about how Dr. Elaine Ingham's assertion that all of the nutrients that any soil needs are always available in the soil, and that just by adding or establishing the correct microbial communities, that you can make these available. And there's been pushback on that, saying that certain elements, especially certain minerals, are not going to appear in the system just when life comes back. Have you reached the limits, or I guess examples or circumstances where just working with biology is not sufficient to overcome all of the challenges?
Yeah, that is true. It is true that soils are chemically out of balance, and it's calcium, magnesium. That's usually a big problem, which I find so weird from the chemical companies. When they do a test and there's a almost toxicity level of magnesium, they still advise to apply magnesium. Don't understand. But yeah, calcium, magnesium is very important. It's the breath of the air. If that's not in check, if that's so out of balance, we need to check that.
Can you explain this relationship from the beginning? Because I've heard a few things about it, but I've never heard it fully explained about the function of each one of those elements in soil function and how they relate to and interact with one another.
Yeah, the important thing is way at the beginning of Earth, right? When it was still hot and cold, that this is where clay was made. Clay is made of minerals that have been heated somewhat and cooled off. So it's a special procedure that happened early in Earth. And then
So
after,
you're saying that there's no mechanism to make more clay currently?
I would think if we studied it, we could probably repeat the heating, cooling process.
Sure, but it's not, we're not making more clay as it currently is. This was
I don't
something that
think
was
so.
formed millions, if not billions of years ago.
Yeah.
Okay.
Yeah, because what's spewed out of volcanoes is so hot that once it comes down, it becomes lava stone, right? So
Yeah,
that's different. It's not clay. But then it takes weathering for the clay platelets to come off, right? And then they stack them together again in soil that is a clay soil. Now, what is clay? It is minerals, really, that have gone through a heating, cooling process, but it is actually a stack of minerals.
Sure.
And because
all types of minerals can be found in clay. I used to understand this as a fact that they have such absorptive qualities and are able to absorb minerals in the environment around them. But you're saying that all of these minerals have also been formed into clay through the heating and cooling cycle.
Yeah, so they're all in there. Yeah,
oh, fantastic. Okay.
And it can be, there are many different types of clay, right? Because of the yeah, and then clay can also oxidize. And so the thing is, those platelets are stacked together like glue almost, right? Because it's very fatty. And so the only way to have them repel is to have the balance between calcium and magnesium, and it's magnesium that holds them together. And apparently it takes 16 molecules that is tied up in magnesium, and that's why it can crack open and dry. But actually it's not that the clay is dry, it's that all of the water molecules are tied up in the magnesium. And so once you get the calcium in there, it fluctuates, meaning you get pores. So now gas can exchange and water can come in. And now it is something that a root system can get into. But that's what we need.
This is so useful. That was the most concise description of that relationship that I've heard so far. I appreciate it. Okay, so with that understanding, now finding a balance between magnesium and calcium in different soils. First of all, you're doing this through a different type of test than microscopy, I assume.
Yeah, because there are chemical tests that people have laying around, and so I don't require them to do a new test, but if it's laying around, I will help them interpret it.
Nice.
Yeah.
Okay, so give me an example of what you're looking for in a chem test that's going to tell you about the balance of calcium and magnesium, especially in your clay soils.
Yeah, so usually that's off. And I know if I solve the problem of calcium, magnesium, most of the other ratios that you can look for in the soil fall into place. So calcium, magnesium is actually a very important balance. And so, but I don't want to put lime or gypsum on there. I'd rather work with organic calcium. And that might be a little bit more slow release, but I think the slower route might be better than a harsh turning left or right with gypsum or lime.
They're a massive direction change.
Yeah.
So organic calcium, how is that derived and applied?
Yeah, I love the calcium that's in eggs. And so there is a procedure where you can get the calcium out with vinegar, and then you have
That's the one I do. I'm very glad that you advocate for that. And I'm not wasting my time. I
love that liquid calcium. I see it to be so effective. I do dilute it because it is highly concentrated then.
Sure, usually it's like 1 to 500 or 1 to 1,000 that they recommend you put that vinegar extract.
Yeah. But it's and there are many other sources. Oyster shell is also good. I have not worked much with it, but I hear other people being very happy with it, and it's slow release.
Yeah, depending on what source you have access to, right? I've even mixed animal bones in with some of the eggshells that I've crushed and then burned in order to get it to a state where it can be extracted by the vinegar. Yeah.
So that's a good thing. And, pay attention to the plants that have the capacity to pump up your calcium. Mm-hmm. Those would be our ordinary beautiful dandelions, but there are many other species of plants, and there's so many websites. What's it called again? Kew Gardens has a huge database of all kinds of plants, including the pioneer plants, plus what they bring up, right? What plants should you select to pump up calcium?
So I'm more familiar with Isa. Our friends shared with me the translations of Gerard Doucet's work, and the
Love.
charts that he's made for corresponding weed species to their ecological function and their pairing of either mineral deficiency or excess.
Oh, it's a treasure trove. That's beautiful, but it's just not database accessible online. But yeah,
Yeah, I'm surprised nobody's done that so far. It's so very well laid out in tables that you can mix and match.
It's
But I've only
beautiful.
ever seen translations from French into Catalan and Spanish. I haven't seen them in English yet.
Me neither. No.
Seems like it would be an easy translation to tackle.
Yeah, and then there is Dr. Heinz Ellenberg. He's also done research on weeds and what properties they have. So, if you're into doing composting, why don't you look up what, plants that you have growing around you, and maybe those happen to be the ones that pump up calcium. They pump it up into their above ground biomass, right? What's above ground, where you can see, pluck them and put them in your compost, and now you have your organic source of calcium in your compost. Right? It's slower, but it is more, and you can apply compost twice a year for sure, which is in the fall and in the spring. And if you need more, because of some problem you're tackling, you can make extracts to battle some problems, or make plant fermented juices, which are very, very effective. You can
I've
do
also
it.
played with those, yeah. I
Yeah.
haven't done enough trialing to say for sure that that's what's working in my system, but I have a number ready to go. And now we're at the end of the season, so it'll be spring when I start applying them. But I'm curious too, because, okay, so now we're getting into a point where compost is still definitely the solution, but you're making up for some mineral or chemical deficiencies through the inputs that are going into that compost. And this takes me back to the presentation that you made for us in that gathering of different recommended recipes for compost to address the typical deficiencies or challenges of specifically soil profiles in the separate biomes of the Iberian Peninsula, which is marvelously specific, absolutely fascinating. And I had questions back during the gathering about this that maybe we can go into again, but before that, maybe give us a description about how you made that resource and how you came up with these different recipes.
Well, I have to thank Ernst Götsch for this. He's a syntropic agroforestry teacher, practitioner.
Yeah, he's the originator of the syntropic agroforestry model.
Yeah. And I'm deeply impressed with him and the way he looks at nature as well. And he tells me, and I can see it, is that nature wants to be something, right? Naturally, nature wants to grow a forest here, or wants to grow grass here because it's more, it's flat and it wants to grow grass. Right. So there is a memory, like I said in the beginning, soil has a memory. And what am I answering now?
We're talking about the recipes that you came up for compost for different biomes around Iberia.
Right. And so when I looked at those biomes, I looked at what nature wanted to be there, because you have to go through old records and see what normally grew there. And you can see very, very old maps with drawings indicating you can hunt deer here, and you can figure out what nature wanted to be there because it grew there naturally. And so that's how I came up with the compost recipes, because that, what do you call that, biological information, that DNA that's already there will respond to it.
Right. And one of the inputs that I saw commonly recommended for many of the biomes here is that of tree bark, specifically oak bark. And I had never heard of anybody specifically working with oak bark or other tree barks in their composting system. But as you explained to me, this is to bring calcium into the mix?
Yeah, and you get a lot of fungal spores as well that you want operating into your system. Yeah,
because it's otherwise very hard to break down. Does this mean that your compost is going to take that much longer to metabolize this material, or?
No, it's just if you do a thermophilic composting, the heat, which should stay between 55 and 65 Celsius, don't go above it. Those are the optimum temperatures for the fungi to break down the lignin. Okay. So if you keep it right there, if you go over, they have to stop that work. So you don't want that. You want to then, if the compost pile wants to run in temperature off, you punch a chimney and monitor it, because it only takes about 12 days to monitor a compost pile, and you don't have to do it the whole day, but just twice a day that you check. Don't worry. But you, and then in 12 days, actually, you finish that process. If you're just keen enough to stay on it for a while, you can produce the most beautiful compost, meaning you're producing microbes that is like a huge army that's going to help you rebuild your soil, protect your plants, and feed your plants.
Sure. So one of the other criticisms that I've heard from the camp that says applying compost is either impractical or not always a solution is often because of the difficulty of applying it at the right time and under the right conditions for it to be as effective as it can. Can you talk to me about some of the considerations for applying either compost or extracts in conditions or in the right time for it to do its job as well as possible?
Well, I really don't understand that criticism. I mean, if you plan to do your fall stuff and your spring stuff, which is in the fall, you want to apply so much so the microbes present can rebuild your soil, which is what they're doing from fall until spring. You reapply again in the springtime planned, right? So it shouldn't be a logistic problem because you've planned it. You apply it, now you're set, right? So let's say you have something you cultivate and it has a lifespan, and you know before it blooms it needs an extra doses of nitrogen of some sort, right? You can plan that. You can see budding, true leaves, whatever you have to do to find the spot in the life cycle of your cultivar. You can apply it planned again because you see it coming, right? Oh, in a week's time, now I have to give it my compost that has extra calcium and potassium because we're going to bloom or whatever. You have your medicinal compost piles. I don't see the problem. For me, it's planning and applying.
Sure. I guess some people have said that the efficacy can be really turned on or off based on the moisture in the system. And applying this either right before or right after a rain is where you get the optimal results. And definitely in places like in Iberia, where rainfall can be so sporadic and unpredictable, even in our rainy season, that this can throw off application. And, depending on whether you can coincide the maximum amount of life and activity in your compost to coincide with when there's a rain so that you can apply it right when it can get down into lower layers or take the water and be effective is where I've heard people having difficulty.
Yeah. So, I would look with you at your climate and what the weather is like and what is more practical and logical to do. Yeah. But, it should not be complicated. It should actually be real easy. And that's more the problem. It's so easy that people make it more complicated to feel like they're doing something.
I've heard that too, for sure. I mean, people can get really, really dense and technical in their creation of these ideal composts and stuff. And I really appreciate yourself and others in our group that got together working really hard to demystify this, to make it as simple as possible, to take out the risk of errors and failure and make it much more approachable and useful for people who haven't done all the studying and the practice that you have.
Yeah. And one more thing, because people are changing over to more regenerative skills, right? Now they're taking it all personally, right? So now the weather is too much rain. Now we have waterlogged conditions because of too much rain, right? And now suddenly it turns against them and they say, I can't do this. You see, I'm not solving the problem. And I go, wait a minute here. We're doing adaptive, right? We're adapting because our climate is changing. Listen, you've had months and months and months of too much rain. This is not just a compaction problem. It's just too saturated, right? So now we have to do a little bit more on waterworks. We have to make sure the water can get away. Let's make a couple of more swales or something like that. But don't take this personally. We have to become adaptive, keep looking at nature and see how we can be supportive. But no, now we pull it to ourselves and say, we're bad. We're doing bad land management. No. The climate is changing. We're needing to adapt with it, right?
Yeah. I think that's a really good point too. Like, none of the strategies or techniques that anybody decides on using are going to work 100% of the time, or are going to continue to work as conditions change in the trajectory of the succession that they're now on. So these early interventions and techniques might be exactly what is required to get it to the next stage and maybe even damaging when you do make it to that next stage. And to say nothing of all of the adaptation required in the variables that are happening in the climate, in the markets, in a lot of cases with farmers, something that you've been growing successfully and that you've really got down a system that works. All of a sudden the bottom drops out of the commodity price and it's not worth doing anymore. It's not because you did something wrong.
Yeah.
Because we have to recognize that we are part of systems that are in constant flux and that are increasingly erratic and unpredictable.
Yeah.
And much more than having a good system that works all the time, you need a variety of tools in your toolbox.
Yes.
And the thought process and the decision-making process to know when to use them appropriately in order to accomplish your kind of larger goals, knowing that there are going to be seasons, there are going to be maybe even multiple years at a time that really conflict with what you had known up until then, and your ability to adapt and react to those pulses in the system are going to determine how quickly you achieve your goals.
Yeah. And so what I'm hearing you say is that we do need this holistic view with many practical stuff in our backpack so that we can respond, right? But you need the big picture to understand, okay, now out of my toolkit, I need to do something about drought because now I have a year of drought instead of drowning in water. Now I need to do something about pumping up the water.
Yeah, absolutely. And this really goes in with so many conversations that I've had on this show that try and bring it back to the patterns that work pretty much all of the time, regardless of the fluctuations that are happening, right? So effective water management is going to bring the moisture into your soil that allows microbes to thrive. If microbes can thrive, then all of this other cycling of minerals and collaboration with other members of the soil food web and the roots of the plants in them are going to be available. As soon as that process stops, when the system is either totally dry or completely saturated, I don't care what your microbial communities look like, they're not going to be able to function effectively. And this is part of why I've spent so much of my time and my focus within the regen ag space on water management. Yes. And why I've also heard from so many soil scientists, including Rachel Creamer, who I was just on a workshop with at La Junquera a couple of days ago, say that so much of what we're trying to do with soil here is to effectively manage moisture. Yeah. And it's actually a lot about the water. Can you comment on that real quick?
Yeah, it is. Water is very important. And actually the whole pattern of our weather holds a story with, it's of course a story of the sun and water. And because we go around, we have wind and weather. But our patterns have completely changed. Basically, it's also due to the fact that we are at the end of an ice age and we've never lived through one consciously. I don't think we didn't have newspapers 11,000 years ago when one was happening. Yeah. So we don't know for sure how an ice age is going to end, but the big worry about water right now, I think, is the Atlantic Ocean slowly going to stop, right? Ever since 1970, it's
talking about the Gulf Stream.
Yeah, the Gulf Stream.
It's basically keeping Europe a much warmer continent than it would be without it.
Exactly. And the extreme rains that we have now are like the precursors, with the other prediction being that America would be hit with more. And all of those predictions have come through. If you see this happen, it's a sign that our Atlantic stream is slowing down. And so, yeah, water is extremely important, and we're going to have to, because I know for sure the Earth will find an answer. It won't just stop. It will have some answer. I don't know what's going to be.
And even if we do end up being this 6th mass extinction event that includes us in it, that isn't to say that the Earth hasn't bounced back from these events before. And as much as it seems like quite a long time to us in our generational terms, the human-propelled destruction of our ecosystems is a tiny sliver of a fingernail of the entire entity that is human time history. So, or not human time, but planetary time history. And it seems like a long time for us, but it's inconsequential on the timescales we're talking about for a planet.
Yeah. Yeah, and the planet probably doesn't mind us trying to experiment. And if we are not getting with the program will be extinct. Yeah, for
Yeah,
sure.
exactly. Like it's more of a self-determination thing rather than are we going to kill the planet? That's not really the question. So one thing
Yeah.
that I want to touch on before we wrap up is, and seeing that there's so many more things that we can cover, and I intend to on later episodes,
Love it.
where do you then take where we've gotten to with our discussion so far and bring it into a list of possible trajectories depending on how we manage our land by, like, how about this? I'll give you a little example. The way that I see it is if we happen to tap into our potential as a keystone species to be able to beneficially manipulate the genetic, the health, and the resilience trajectories of the ecologies that support us, then we can start to be or find ourselves in a world where this macro ecosystem is reaching heights and possibilities that we never thought possible. This only can be achieved with very robust relationships that keep an otherwise very erratic system in homeostasis or in balance. But we can unlock potential for life that then maybe makes it feasible or interesting to start to look at colonizing other planets, but not until we actually find a way of mastering our role. And our role is, I do not believe, controller of all things, but rather facilitator of many, many processes. We have demonstrated an ability to do this if we choose to, as just as much as we have demonstrated an ability to degrade this if we choose to. And then it might start to look interesting to bring life to other planets and to colonize other parts of the solar system, but only after we've reached the upper limits, not scraping the last resources in order to flee out of fear, but bring the abundance and the resilience that we are potentially able to achieve here to other places. Where do you see our possibilities and this knowledge that you've described so far taking us?
Well, yeah, I think that's the trajectory of the microbes, right? In inspiring us to get off the planet, which is what the next step of the microbes is. Let's look for more life outside. But I think the answer to this is love, actually. You won't pay any attention, or you will not generate all of your or organize your energy unless you find something to be very important, right? It is what you love is what you will research. What you love is what you will try to understand. And if it's something you'd love, it's something you'd want to work for. Now, I think that that's most likely is the best answer. And it's not just love of the planet, because, I mean, that's a real great step. And it's easy because it's easy to love fuzzy, beautiful, cuddly animals, etc. It can generate a lot of love inside you for looking at beautiful flowers, for example. But what's way more difficult for us humans is to just simply look at ourselves and love ourselves, and be aware of that we're each and everyone is a complete, unique something. And how interesting is that? And why not love it?
Yeah. No, I mean, it is the emotion and the capacity that brings out the best in everyone.
Yeah.
And there are so many ways of expressing love, right? We see it in romantic expressions. We see it in family and friend expressions. We see it even in abstract concepts and worldviews. And when this is properly leveraged or understood or cultivated into something, it becomes a verb, right? Loving. And what that looks like in all of these different scenarios are what bring about the higher potential of not only the individuals involved, but the interaction and the relationships that are bigger than the sum of their parts, right?
Yeah, and if love is a scary word for you, because for some people it's such a private word that it only happens in your family, in your direct family, and nothing outside, and even in your family you don't ever say the word love. If there's something that really gets you excited, that's tapping into the same thing, right? Yeah. Because if you get excited, you're willing to learn, you're willing to understand, you're willing to work with it. And so if love is too painful a word, let's call it excitement.
Okay. And if love is too painful a word, let's also go to therapy and come to terms with it, because it's a beautiful thing to have. It's too beautiful of a thing to have an aversion to, right?
Yeah.
That would be a shame. I mean, I have definitely lived in and grown up around cultural norms where expression and affection are not common. And I have lived in others where they are the center of interactions between all types of relationships. And I definitely prefer the latter, which is part of why I've been so attracted to Spanish and Latin American cultures, which are very expressive and very affectionate, and that sits well with me. But I definitely, let's say, understand or have empathy for cultures which are a lot colder in the way that they express their emotions. But I think we could all stand to advance, or let's say grow in that way, and be less standoffish with that concept.
Yeah. Oh,
Excitement doesn't quite cover it.
no,
Yeah.
but it taps into it.
And it's maybe a gateway for people who are less in touch with the full meaning and expression of love to get back into it. Yeah, I love that. Tanja, we're about running out of time today, and I know we're going to follow this up another time, so I'm not going to try and push everything into this one conversation. But before we go, can you tell our audience how they can get in touch with you, learn more about the work that you do, and maybe even solicit some assistance?
Yeah, you can reach me with my email address, which is tanja.dekker with double K at freedom.nl, freedom as in freedom. Yeah, right. It's really, lately, I really love to teach. So, but any job that comes my way, actually everything that I've done the last year, I've said about, oh, this is what I want to do now forever. And then they're completely different projects. So actually, I love all of the work.
Well, that's really important. You are in love with the work that you're doing and the expressions that are coming from that. What a perfect way of bringing that all full circle. Tanja, it has been not only a joy having this conversation, but also just getting to know you in our gathering last time. And so many beautiful things have come up since that group has gotten together, and we're moving more and more towards collaboration. And so much of that has been instigated by you and your knowledge and your passion for these topics that have propelled so much connection between this group and between your students and other people that you've affected. I just want to say thank you for that. And I really look forward to more conversations very soon.
Thank you. Yeah, I love it. I'd love to come back.
Now, before we wrap this up, just remember that these episodes are only the beginning of the learning resources, design and coaching services, in-person courses, and interactive community that are available through Regenerative Skills. The Discord server is our free community where you can connect with other like-minded listeners, exchange ideas, stories, tips, and resources, as well as interact with me directly and quite a few former guests from this show. Our Instagram account @regen_skills is the best place to see the projects that me and the team are working on, both for clients and collaborators, as well as on our own properties. I'll also be announcing the certification courses, workshops, and gatherings that we've got coming up later this year. If you're interested in getting dedicated support for your own project, you can now schedule a free planning session with one of our team members through the request form on our website. You can also find all the links, show notes, and past resources there at regenerativeskills.com. We truly believe that no matter your experience, your knowledge, abilities, resources, or background, you can be a powerful force for regeneration on this planet, and we're here to help you find your path. So as always, remember to keep taking those little steps every day towards a regenerative future, and I'll be right by your side along the way.